In this video, I will explore a crucial concept in chemistry, the breaking and making of chemical bonds. Have you ever wondered why some things dissolve in water while others don't? Or how your body is able to digest the food that you eat? Chemical bonds are the forces that hold atoms together within a substance, just like these potassium atoms inside a metal and these hydrogen and oxygen atoms inside water. There are different types of chemical bonds, including metallic, ionic, and covalent. How can you best model the breaking and making of bonds during a chemical reaction? One way to do that is by using so-called Switchits, as advertised by Paul Andersen from Bozeman Science. Switchits are both magnetic and contain dry erase tops for writing. A great all-around educational tool, and I can't wait to use it myself. Can you say that 10 times fast? Switchits. Oh, and this picture of Paul Andersen and me was taken back in August 2019 at an educational conference in Newark, New York. I've got a few more gray hairs now. But in this video, I will go through a web-based chemical bond simulation that I have used with my chemistry students. It could help your students understand better that breaking chemical bonds requires energy, while making chemical bonds releases energy, as shown in this simulation involving the reaction with potassium in water. This NetLogo simulation was developed at Northwestern University's Center for Connected Learning and Computer-Based Modeling. This simulation is part of the storyline lesson titled, "Why do some things get colder or hotter when they react?" I adapted this very storyline from the Next Generation Science Storylines and the Inquiry Hub chemistry curriculum. Check the description below for more information, as well as a Google Drive link to my adapted lesson handouts and my keys. You're welcome. The video link shown above contains my summary of the first half of this storyline. But before I start with this simulation, let me know in the comments whether this storyline or components of it is something you wish to incorporate in your chemistry lesson. I would love to find out. All right, we are at the NetLogo Web Bonds and Chemical Energy site. I'm going to hit the refresh button so that I can show you this is exactly what it would appear like for you and your students. So we are noticing a big, gigantic, rectangular black box. Let's go look and see what's inside. Click Setup first. All right, what do we notice? We notice Object 1 and Object 2. These two objects, we can manipulate them. Object 1 has actually the ability to exert a magnetic force. So we have right now a strength of 0 and a position of -40. And we can manipulate that by simply going from 0 all the way to 8. If we up the strength to 8, the only way to actually see that you've exerted that strength now or applied that strength is by hitting Setup again. And all of a sudden you see all the arrows pointing towards this Object 1, this now very strong magnet. I'm going to set it back to 0. And click Setup. Object 2 at this very moment in time has a strength of 6. Again, we can change that. Let's up it to 8. Again, we click Setup and we can see that that's increasing the arrows pointing towards Object 2. Alternatively, we can drag it over to 0, click Setup again, and gone. There is now no magnetic force applied to this Object 2. Let's now look at the marbles above this line, or the so-called ramp. We have an Object C, or Particle C. Let's call it Particle C. Particle C is situated right now on top of Object 2, and Particle B has a gray color, which basically suggests that this is our metallic particle. So it will be influenced by a magnetic force that you can apply to either Object 1 or object 2. There's a third particle that we can bring into this screen, but let's first set it up so it makes sense to bring that third particle into it. Okay, I'm going to up the strength, let's make it strong, 8 to object 2. At this moment in time, particle C at 10 millimeters is roughly at the same spot as object 2, 10 millimeters. Object 1, I would like to position B on top of object 1 and also give it some strength. Okay, since in the video earlier we were modeling potassium in water, which is an exothermic chemical reaction, I'm going to make the strength of object 1 not quite as high as the strength of object 2. Because this is an exothermic reaction, so I'm going to model how B is going to bond to object 1, magnet 1. So let's first position it on top of that and set that up. And if I bring in this new particle A that you're not seeing yet, then we can kick off particle B, which again is metallic. It will transfer its energy over to particle C, which is non-metallic and sits right over magnet 2. And then we can see what happens in terms of bond breaking and bond making. But we first have to give this initial speed of particle A, again not yet visible, a value. Value 0 is not much of a value. So I'm going to, I don't know, let's go with 4. Let's go whopping max. Let's hit setup. And now that I can hit go, I can see what's happening. Take a close look at this left field because it's going to show you the speed of the various particles in this field. Soon you will see A, B with a different color, gray, A is green, and C is represented in orange. One more thing that I want to do before I actually hit go-pause is reduce this bar right here, because let me show you what happens if I hit go right now. Okay, I may seem smart to some people, but right now this went so fast I couldn't really understand what was happening. So I'm gonna pause it. I'm gonna click setup again, and I'm going to move this over so it's a little bit slower so we can talk about what's happening as it is happening. Okay, so particle A is moving in with a certain amount of kinetic energy, set at 4. It's going to collide with B, and it's going to transfer its energy completely to B. B is going to move towards C, and C is not connected to object 2 because C is not metallic. B just moved away from object 1, magnet 1, and is now trying to bond with magnet 2. Remember, we said magnet 2 to 8, whereas magnet 1, object 1, was only 4. So stronger bonds could be formed, weaker bonds are broken. And that's why this may actually model an exothermic reaction. Now, what you're noticing as well here is that B is kind of wobbling, oscillating back and forth right above magnet 2. Now, the reason for that is that this particular track is set at a friction of 0%. So that means this wobble could go on for quite a while. So if you actually were to up the friction, and we can do that while it's playing, it should actually stop after a while. And you see the graph is slowly reducing for the gray, follow the gray line. And then that bond has truly been formed more stably. Okay, so again, this particular simulation can show you two different objects, object 1, object 2, to which you can apply different magnetic force. You have 3 particles, particle A, non-metallic, particle B, metallic, particle C, out of the window, also non-metallic. But it's all about that B. How much energy does it take to break that bond, simulated by the speed that A needs to have to kick B off, and how much energy is given to C in order for B to make that bond. And so you can now measure both energy inputs and energy outputs right here in this diagram. I think that's powerful. I'm back. So I hope you took something away from this simulation. Don't despair if you felt a bit overwhelmed, because I'm showing you here again that all the lesson handouts and the keys are right in the description below in a Google Drive link. This was actually storyline lesson number 9, which encompasses 3 investigations, and it takes your students bit by bit through these simulation steps. This is investigation 1, again out of 3 for lesson 9, investigation 2, and investigation 3. The culminating investigation is actually the one that I showed you, where you're putting together the breaking and making of bonds into the simulation. So I haven't quite completed that key yet, because I'm literally just doing that lesson right now with my students. So shh, don't tell that it's already on YouTube, okay? So just to let you know, I do want you to be aware of the New York State Science Learning Standards, or the Next Gen Science Standards, that these are connected to. It says here HSPS 1, Matter and its Interactions. Take a look. And then finally, I hope you took something away from the 2 models that I showed you. Remember the bond and energy simulation, as well as the Switchits, the magnetic blocks with the dry erase surfaces on top. In closing, I would love to hear what lesson plan you wish me to share in my next video. Leave me a message in the comment and let me know. Thank you for watching. Bedankt voor het kijken. En tot ziens. See you in the next video.